In this video clip, we are going to look at the I/O ports of a microcontroller. A microcontroller is a complete computer system. It has CPU, memory, and lots of I/O peripherals. What is the minimum circuitry we need to hook it up to make the microcontroller do work for us? First of all, like any other electronic components, we need to provide power supply to it. A microcontroller is a large digital system in which there are a lot of switching between 1 and 0 in a very high frequency. This high frequency switching generates a lot of digital noises, feeding back to the power supply and interfering other components. To reduce these noises, decoupled capacitors are used between the VCC and ground pins. These decoupling capacitors must be connected as close as possible to the VCC and the ground pins. One decoupling capacitor for each pair of VCC and ground pins. An external crystal that provides the clock to the system. An external reset circuit by using RC charging circuit. When the power is first turned on, the voltage across the capacitor is 0. R times C is the time constant for the charging circuit. It takes the time equivalent to one time constant to charge up to 67% of VCC. This voltage is connected to the reset pin to reset the microcontroller before the voltage is charging up to VCC. A microcontroller may have an IDC built-in. To reduce the digital noise which may interfere the analog circuit, the IDC has its own power supply, which is separated from the digital power supply. The user manual of AVR microcontrollers recommends to connect the analog VCC to the digital VCC through an inductor. An inductor allows DC current to go through and blocks the high frequency AC, which is the noise in a digital system. The external crystal is for you to generate a clock for the system, but this is not the only option. The microcontroller has internal RC oscillators, which is you can enable it and use it as the internal clock generation. In that case, you don't need to have an external crystal. The same for the reset circuit, and you can enable the internal brownout reset to reset the circuit when you power on, so that you don't have to use the external RC circuit at all. So that from here you can see a complete system. You only need to connect the VCC for the digital system and also analog GCC for the IDC inside. After we provide the power supply to the microcontroller, it will work for you. The problem is if you don't connect anything to the I/O port, and then doesn't matter how powerful the CPU is, you don't have anything from it. So we need to connect something to the I/O port. This microcontroller has 7 I/O ports. Most of the pins has multiple functions because the number of pins are limited. The first port is port I. As you can see, you can use them as the general input and output, and also can be used for address bus and data bus if you connect external memory to the microcontroller. Port B, so general input and output, and also have some other functions. One of the important one is SPI, one of the serious communication protocol. We are going to discuss this later. Port C, general input and output, and also can be used as the address bus when you connect external memory chip to the microcontroller. Port D, general input and output, and also have a UART protocol connected to some of the pins. Port T, general input and output, and also have another UART protocol connected to some of these pins as well. Port F, general input and output, and also the connection for ADC. If you use the analog to digital conversion, the analog signal will be connected to one of the pins in port F. And last port is port G, which is if you connect the pin using external memory chip, they will be the control box. And this port doesn't have 8 pins. All pins in the I/O ports can be used as general-purpose input and output. When used as general-purpose I/O, the equivalent circuitry of each pin is similar. Here is the internal circuitry connected to the external pin. There are 2 protection diodes. Look at the polarity. In normal operation, the voltage applied to the external pin is less than VCC, so the upper diode is off. If the voltage at the pin is greater than VCC, the upper diode is on. Because the diode is on, the voltage across it is about 0.7 volt. This means the voltage connected to the pin is now pulled down to near VCC. In normal operation, the voltage at the pin is greater than 0, so that the lower diode is off. If the voltage at that pin is negative, the diode is turned on. Because it is on, the voltage across it is about 0.7 volt. This means the voltage at the pin is now pulled up to near 0. These 2 voltages guarantee the voltage at the pin is within 0 and VCC, so that the circuitry inside the microcontroller will be protected. There is an optional pull-up resistor. You can enable it or disable it. The I/O pin can provide symmetrical sink current and source current. The sink current is the current flowing into the microcontroller. The source current is the current flowing out of the microcontroller. Both currents are strong enough to drive an LED.